first one I wanted to talk to you about. That
knocking on the table.
Sorry, man.
I'm going to derate you in a minute. You get fired halfway through the first show. Go on.
I'm out. Just run me through again, because I briefly spoke to you before this, just about the temperature chart.
Yeah.
Okay. So one of the things you were saying about is with the 19%, the 21%.
Yeah.
Right, just run me through how that works, because I've spoken to people previously about this and they're like, right, okay, I kind of get it, but I don't get it. So I just want more clarity on that one.
So you're talking about a thermal derating chart.
Yes.
Now, there's only a few manufacturers actually I found. I thought it'd be a bit more common because like if you're fitting a consumer unit or an RCBO from anyone, I thought it would be more accessible, then the information would be more accessible. I found out since, after speaking to Paul, why it's not, right? But what it is, essentially, it is just a simple chart which will start at 30 degrees. I'll explain why in a bit. But it will start at 30 degrees, and that's the testing parameter heat for your certification and your standards of BSEN. I think it's 69001 for the RCBO. So all the RCBOs are tested at 30 degrees, okay? And that's to make sure that they trip at the right amperage. So if you've got a 6 amp breaker, for example, you want it to trip at 6 amps or over 6 amps, right? Yeah. So what you don't want it to do is trip under it, because that's a nuisance trip, and you sure as hell don't want it to trip over it because that's a risk, okay? And obviously the greater it does either one of those, the greater the nuisance or the greater the risk. So what a thermal derating chart will tell you is how the thermals surrounding that product, i.e. at what temperature the amperage will change to. No, that's really badly said. The amperage will change depending on the temperature, right? And the chart will show you, depending on what temperature that environment is in, at what amperage that breaker will trip. There you go. That's better.
Bit of a tongue twister there.
Yeah, sorry. So that thermal derating chart will show you from 30. And if you look down at 30, and it won't just be ours, it'll be everyone's, right? So at 30, you'll have 6, 10, 16, 20, 25, 32, 40, 50. Bang, boom. They'll all trip at that point at that degrees. Well, they should. Okay. Now, then it goes up usually in gradients of 5. So go up from 35 up to 60, and from 25 down to minus 5, I think ours goes. Yeah. And as you follow the columns either way, the next figure will be the amperage in which that breaker will trip. Okay. So I'll flag up ours on the screen at some point, okay, so the guys can see. And I'll also put a link in the show notes so you can download ours and have a look. And you'll see, as you follow up the temperature, that tripping capacity reduces. Top of my head, when we get to 60, I think a 6 amp breaker goes from 6 to 4.8.
Yeah.
And then if you go from 30 all the way down to minus 5, I think it's 7.4.
Something ridiculous.
Yeah. So on a 6 amp breaker, for example, on our derating, which is one of the smallest derating factors in the industry, there's still quite a considerable difference. And obviously on a 6 amp breaker, you're going up to 7.4, you're going down to 4.8, okay. But on a 50 amp breaker, I think it goes all the way up to 59.8.
Something ridiculous.
On the minus 5, and I can't remember how much it reduces at 60 degrees. I think it's 40 something off the top of my head. Anyway, so if you map that out on ours, which I think is only a 19% derating factor, that's still something that you're going to have to factor in to your electrical design. Not really ever going to be an issue in your standard domestic setting. So if you're looking at a consumer unit, you change the board, you've upgraded it to a Verso consumer unit, those devices there, you can fit in the ambient temperature of a home is anywhere between 17 and 24. The running temperature of our RCBOs is, it's actually the lowest in the industry. So you're not going to get an environmental change too much to the board. And therefore, the derating factor is going to be very, very minimal, if at all. So you'll be fine. And there are other manufacturers in the industry that are similar. Yeah. There are other manufacturers in the industry that are not, right, where their derating factor is up to 40%. So now you're calculating 40, that's not from 5 degrees, that's from 30 to 60 and from 30 down to minus 5. Right, okay. But the differential is up to 40% at either end of that scale. Well, 40% of 50 amp, for example, especially on a derating factor at minus 5, is huge. That's dangerous. That's risk, huge risk. And again, upwards, you're just talking about nuisance tripping to the point where it could become unlivable. Like, and you're going to get a callback like this is ridiculous. Again, unlikely to reach those extremes in a domestic setting because the ambient temperature of the sphere of the board isn't that high. But when you start filtering that back to people fitting consumer units outside or in other environments, whether either warmer or colder or have a fluctuation temperature, mate, that's massive. Again, you really got to start thinking about how you can control the environment of those devices as much as you possibly can. Even when you're fitting a higher pedigree product like ours, for example, you are still, if you're going to stick it outside, for example, and you mentioned the peaks of Scotland.
Yes.
That gets cold. You fit in a board outside in Scotland. I actually had one electrical contractor on Instagram reach out to me and say, when I did the video on IP boards outside. Yeah. And I mentioned obviously rain doesn't go upwards. Apparently in Scotland it does.
Does it?
I think it's the wind. So as the rain comes down, obviously the wind is so high on the peaks of Scotland, it kind of scoops it up.
Right. Okay.
And it can hit the bottom of a consumer unit, because normally if they're fitting them outside, they should. They should. I've seen some that don't gland it from the bottom, right? But some do still gland it from the top. But in the theory, obviously, that rain doesn't go up. But apparently in certain areas of Scotland, rain doesn't go up. And so, you are really at risk of the elements anyway. So inside a home, generally safe. The only thing I would say is if you've got a number of larger circuits, especially if you're using these brands that have a high derating factor, don't group the larger circuits. And if you are going to put a lot of them in, just space them out. Blanks. Yeah. I mean, use a DIN rail blank, or if you don't have space, use a DIN rail blank. Maybe just look at grouping smaller circuits next to larger circuits to reduce that kind of conductive heat. But yeah, it was surprising me when we put that video out how many electricians still weren't aware of it. Okay, now it is something that tends to affect RCBOs far more than anything else, just because the running temperature of them is higher. As a standard than other devices. That would also include obviously AFTDs, because AFTDs are a combi between obviously an arc fault detection device and an RCBO. Yeah. So you got a situation there. So it was really it was a good topic. I mean, a few people had some questions in this and the other. We'll probably make a follow-up video on it. But but a lot of people, there was one but in particular, I think it's Paul from E5 mentioned, great topic. You didn't even go deep enough, because we didn't, to be fair. We literally just touched on the surface level of thermal derating. Yeah. But it does seem like it's something that more electricians are becoming aware of. Okay. No manufacturers are talking about it. And it does affect electrical design massively, especially in certain environments. So I think it's something we'll dig deeper into. Yeah. And again, guys, if you are watching or listening and you'd like to know more, and there's a specific area of thermal derating that you've got a question about, get in touch. If I don't know yet, I'll find out, and we'll do a presentation on it and see if we can educate you that way.
Just to stop you there quickly, the thermal derating chart, do all manufacturers have that?
No, and the reason they don't have that, as I found out, is because the testing you have to do to basically gather that data, it's not a requirement, believe it or not, for a BSEN standard product. It's also not a requirement for an awful lot of certification standards. Wow. So there's a lot of people say, it's independently tested. Brilliant. But that's like saying, unless you know by who and what the parameters are they're testing, that doesn't actually carry much weight, does it? So, and even within certain testing houses, like the one we use in Germany, they have different standards of certification. So you can carry their badge. Yeah. All right. But at the same point, you've got like the entry level of their testing, or you can go to the level we do so we can get our specification work, and it costs 4 times as much. But the actual testing you have to do to be able to gather the information to do those thermal deratings to each end on every device, a lot of factories in China especially do not have the capacity to do it, which means they have to then outsource that, which is tens of thousands of pounds per device. So that's why they don't do it. So there's one company that I know, Hager do it. Hager advertise theirs. Obviously, we've got ours. I say advertise, that's strong. They obviously make theirs available, which I thought was really good, which is why we did it. Yeah. I think you can get older Schneiders. Okay. Wilex or another one. So Electrium. Again, the brands you would expect to be able to get it from that have always carried weight in the circuit protection industry as far as credibility is concerned, you can access it from. Right. So, and obviously we've always tried to either exceed their standards or at least match them as a bare minimum. So that's why we've done it. But a lot of other brands, shall I say, nope.
Do you think it's a case of them unwilling to be transparent because they're scared as to what their feedback will be?
Not always. With some probably, but I think a lot of it is electricians still don't know to ask for it, so they're not thinking about factoring it into their designs. So they're not asking for it, so they're not having to provide for it. The other one is obviously the cost. You know, you got to weigh it up. If you only want to pay a £5 for an RCBO, well, then you're going to omit certain situations from that situation, right? So if you're only paying a £5 for it, then you only expect a £5 worth of support, right? That's not just on the product, that's on all the other infrastructure as well, which means certain stuff that you're going to get from other brands is going to be missing because they can't afford to sell that for a £5 and then hit the standards of like certain testing standards or information and data. It's just impossible. So, you kind of, a bit boring, but like you get what you pay for, don't you? So,
Valid point. In the video, you talk about the ambient.
I'll chop your hand off.
Sorry, mate.
I am going to chop your hand off.
It's my nerves.
It's your nerves. Should have had that coffee.
You mentioned quite frequently about the ambient temperature. My question is there a right or wrong place in terms of installing the fuse board in the house? Is there a specific place that you would say, I recommend you install in here, or...
No, I mean, just internally, really. I mean, if there's a room for whatever reason in the home that emits an awful lot of heat, like I wouldn't stick it above boiler, but I don't think you actually can anyway. But no, in a standard domestic dwelling in the UK, I don't think there's any way you can't. I mean, legislation aside, I don't think there's any way you can't get away with it. The loft, maybe be a bit aware of the loft, but again, most of those are quite well insulated these days. And well, to be fair, some PV systems and stuff now, they do put all the brains of the house in the loft because there's a lot and they're trying to hide it, right? But again, would it dip that low? I wouldn't have thought so, but it's something to be aware of, I suppose, if you're putting in a loft. Or if you've got like a cellar, a basement type, one of posh house like that. Maybe, but again, I'd assume